Hello, lovelies. You're welcome to yet another interesting class. In the last lesson, you learned indices and standard forms. In this lesson, you're going to learn about quadrilaterals. So, what is a quadrilateral? A quadrilateral is any plane shape with four sides. The sum of its interior angles is 360 degrees. Some real-life examples include your notebook where you're taking down the notes of this lesson, the laptop or device where you're watching this video from, the money you use in buying some nice stuffs, the tabletop where you sip your morning tea, the door where you pass through to enter into your house. All these are life examples of quadrilaterals. Now, let's take a look at the properties of quadrilaterals. There are three basic properties of quadrilaterals. 1. It has four sides. 2. All the four sides must be enclosed. That means that there must be no gap between the line segments that form the quadrilateral. 3. The sum of internal angles is equal to 360 degrees. Based on these properties, there are 6 different types of quadrilaterals. 1 is the rectangle, 2 is a square, 3 is parallelogram, 4 rhombus, and 5 trapezium, 6 kites. All these are different types of quadrilaterals. Now here is a house. Can you identify some quadrilaterals in this house? Of course. The door here is a rectangle. Can you identify another quadrilateral? This window is a square. What about this kite? Can you see this traffic light? It's a rhombus. What about this tabletop? A trapezium. Now, let's go on to look at the properties of the different types of quadrilaterals. The first quadrilateral we'll be looking at is the rectangle. A rectangle is a four-sided shape with 2 opposite parallel sides, and those parallel sides are equal to each other. A rectangle also have each interior angle which is equal to 90 degrees. When you sum it up, it is equal to 360 degrees. Also, a rectangle has 2 diagonals, and the diagonals bisect each other. Let's take a look at another quadrilateral, the square. The square is also a four-sided shape with all its sides equal. Each interior angle is equal to 90 degrees and they sum up to 360 degrees. Also, the square has 2 diagonals. The diagonals bisect each other and it's at 90 degrees. Let's take a look at another quadrilateral, the parallelogram. The parallelogram is also a quadrilateral. That means it has 4 sides. The opposite sides are equal and parallel. Also, the parallelogram have opposite angles which are equal. The diagonals bisect each other. The sum of 2 adjacent angles is equal to 180 degrees. So take a look at these adjacent angles A and B. This means that if you sum them up, they will give you 180 degrees. Also, B and C are also adjacent angles. B plus C will be equal to 180 degrees. Can you think of some other adjacent angles? Yes, C and D and A are all adjacent angles and they sum up to 180 degrees. Here is another quadrilateral, the rhombus. The rhombus is a quadrilateral with all its sides equal. Also, opposite angles are equal. The diagonals bisect each other perpendicularly. That means they bisect each other at 90 degrees. The sum of the adjacent angles is equal to 180 degrees. Now, let's look at the trapezium. The trapezium has one pair of opposite sides, and the opposite sides are parallel to each other. The kite. The kite has two pairs of adjacent sides that are equal. If we name this kite side A, B, C, and D, AB is equal to AD. Why? Because AB is adjacent to AD. Similarly, BC is adjacent to DC, hence they are equal. Also, the kite has two diagonals. The diagonals bisect each other at right angles. The shorter diagonal cuts the kite into two isosceles triangles, and the diagonals are perpendicular to each other, meaning AC is perpendicular to BD. Also, it has one pair of opposite angles, and these opposite angles are equal. Now let's look at the connection between the different quadrilaterals. Here we have properties. You should have noticed that these properties can be grouped into three, which are the sides, the angles, and the diagonals. For the sides, we either stated that they are either all equal, the opposite sides are equal, the opposite sides are parallel. For the angles, we stated that all angles are equal, opposite angles are equal, and sum of two adjacent angles is equal to 180 degrees. Therefore, diagonals, the properties covered, they bisect each other and they bisect each other perpendicularly. Now let's check these properties for all our quadrilaterals: rectangle, square, parallelogram, rhombus, trapezium, and kite. Now, are all the sides equal in a rectangle? Of course, no. Are opposite sides equal? Yes. Are opposite sides parallel? Yes. Are all angles equal? Of course, yes. They are equal to 90 degrees. Opposite angles, are they equal? Of course, yes. The sum of two adjacent angles, are they equal? Of course, yes. Do the diagonals bisect each other? Yes. But do they bisect each other perpendicularly? Of course, no. Now let's check these properties for a square. Are all the sides equal? Of course, yes. Do the opposite sides, are the opposite sides equal? Of course, yes. Are the opposite sides parallel? Yes. Are all the angles equal? Yes. What about the opposite angles? Are they equal? Of course, yes. They are each 90 degrees. What about the sum of two adjacent angles? Is it equal to 180 degrees? Of course, yes. Do the diagonals bisect each other? Yes. Do they bisect each other perpendicularly? Of course, yes. Now let's go for the parallelogram. Are all the sides equal in a parallelogram? Of course, no. Are the opposite sides equal? Yes. Are the opposite sides parallel? Of course, yes. Are all the angles equal? Of course, no. Are the opposite angles equal? Of course, yes. What about the sum of the adjacent angles? Is it equal to 180 degrees? Of course, yes. Do the diagonals bisect each other? Yes. Do they do so perpendicularly? Of course, no. The rhombus. Are all the sides equal? Yes. Are the opposite sides equal? Of course, yes. Are the opposite sides parallel? Yes. Are all the angles equal? No. The opposite angles, are they equal? Yes. What about the sum of the two adjacent angles? Are they equal to 180 degrees? Of course, yes. Do the diagonals bisect each other? Yes. Do they bisect each other perpendicularly? Yes. Now the trapezium. Are all the sides of a trapezium equal? Of course, no. Are the opposite sides equal? Of course, no. Are the opposite sides parallel? No. Are all the angles equal? Of course, no. The opposite angles, are they equal? No. The sum of two adjacent angles, are they equal? Of course, no. Do the diagonals bisect each other? Of course, no. Do they bisect each other perpendicularly? Of course, no. Let's look at the kite. Are all the sides equal in a kite? No. Are the opposite sides equal? No. What about the opposite sides? Are they parallel? Of course, no. Are all the angles equal? Of course, no. Are the opposite angles equal? No, we only have one pair of opposite angles that are equal. Are the sum of the two adjacent angles equal to 180 degrees? Of course, no. Do the diagonals bisect each other? Of course, yes. Do they bisect each other perpendicularly? Yes, of course. Now, this is what I want you to do. I want you to look at this table carefully and pen down the connections you can find between these quadrilaterals. We will discuss about your findings in class. You have come to the end of this video. Congratulations! There are some evaluation questions underneath this video. Do well to answer them in your notes. Until next time, bye!